In the not-so-distant future, a zoologist studies an animal that has been extinct for 600 years. A paleontologist examines a dinosaur bone that is millions of years old, and a biologist holds in her hands the first mammal clone born from an extinct species. This may sound like something straight out of a sci-fi movie, but in reality, it could become a part of our future if scientists succeed in decoding the past. Now, have you ever wondered if it's possible to bring back a creature that has been extinct for hundreds or thousands of years? Or do you want to know how close we are to making this a reality? If yes, then stick around till the end of this video, because today we're going to talk about how we can decode the past. Bringing back a creature that has been extinct for hundreds or thousands of years seems like a far-fetched idea, something that only belongs in science fiction movies. However, recent advancements in genetic engineering and cloning technologies have made this a real possibility. Scientists are now exploring ways to use ancient DNA to create hybrid embryos or even fully cloned individuals of extinct species. So here's how we can decode the past. Step 1. Finding ancient DNA. The first step towards bringing back an extinct species is to find well-preserved DNA from that creature. This can be challenging as DNA breaks down quickly after death. However, in recent years, scientists have been able to extract usable DNA from fossils that are hundreds of thousands of years old. One example is the successful extraction of Neanderthal DNA from a fossil found in Siberia. Step 2. Choosing a species. Once scientists have obtained some ancient DNA, they need to decide which extinct species to bring back. This is a difficult decision as there are many extinct species that could benefit from being brought back, such as the dodo bird or the passenger pigeon. Step 3. Creating a hybrid embryo. The next step towards bringing back an extinct species is to create a hybrid embryo. This involves taking the extracted DNA and inserting it into the egg cell of a closely related living species. For example, scientists may use the DNA from a woolly mammoth and insert it into the egg cell of an Asian elephant. Once the embryo has developed to a certain stage, it can be implanted into a surrogate mother, in this case, an Asian elephant. Step 4. Cloning an extinct animal. An alternative to creating a hybrid embryo is to clone an extinct animal directly. This involves taking the extracted DNA and inserting it into an egg cell that has had its nucleus removed. The egg cell is then stimulated to divide and develop into an embryo, which can then be implanted into a surrogate mother. This method has already been used to successfully clone several species of mammals, including sheep, cows, and horses. Step 5. Bringing back the species. Once the embryo has developed into a fetus and the pregnancy is confirmed, scientists can officially declare that they have brought back a species from extinction. This is a momentous occasion as it represents the first time a species has been brought back from the dead. However, it's important to remember that this is not the same as bringing back a species in its entirety. Even with the help of genetic engineering, we will never be able to bring back all of the individuals that once lived. It's important to note that while these steps may seem straightforward, they are actually extremely complex and require a great deal of scientific expertise and resources. Additionally, there are ethical considerations that must be taken into account when working with ancient DNA and extinct species. However, the potential benefits of being able to bring back extinct species, such as advancing our understanding of genetics and evolution or even bringing back species that could help us combat climate change, make it an area worth exploring. Challenges in decoding the past. Although the idea of bringing back extinct species is exciting, there are several challenges that scientists face in their quest to do so. Firstly, finding well-preserved DNA from extinct species can be difficult as DNA degrades quickly after death. Secondly, choosing which species to bring back is a complex decision with ethical implications. Thirdly, creating viable embryos through either embryo splitting or somatic cell nuclear transfer requires expertise and resources. And finally, bringing back a species from extinction does not mean that the species is saved, as it still faces threats in the modern world. Scientists have come closer than ever to bringing back extinct species with the discovery of well-preserved ancient DNA from various sources. In 2010, scientists in Russia announced that they had extracted DNA from a woolly mammoth that was found frozen in Siberian ice. The DNA was extracted from a hair sample and was estimated to be around 40,000 years old. More recently, scientists have been able to extract usable DNA from fossils that are hundreds of thousands of years old. For example, in 2022, a study published in the journal Nature Communications reported the successful extraction of Neanderthal DNA from a fossil found in Siberia. The DNA was extracted from a bone fragment and was estimated to be around 200,000 years old. The fact that scientists have been able to extract usable DNA from ancient fossils suggests that it may be possible to bring back extinct species that lived relatively recently. However, it's important to note that the DNA found in fossils is often fragmented and degraded, which can make it difficult to obtain complete genetic information. Scientists are considering bringing back several extinct species, each with its own set of benefits and challenges. One of the most popular choices has been the dodo bird, an iconic flightless bird that went extinct in the 17th century. Bringing back the dodo would not only be a remarkable scientific achievement, but it would also serve as a warning to future generations about the dangers of extinction. Another intriguing option is the Tasmanian tiger, a marsupial wolf-like creature that was hunted to extinction in the 20th century. Bringing back the Tasmanian tiger would allow scientists to study one of the most famous Australian animals that went extinct and could potentially lead to the discovery of new and innovative ways to preserve endangered species. However, it's important to consider the ethical implications of bringing back any extinct species. By doing so, we would be altering the natural balance of the ecosystem and could potentially cause more harm than good. As technology advances, the cost of bringing back extinct species is likely to decrease, making it more feasible for scientists to explore this option. However, it's important to consider the ethical implications of doing so and to proceed with caution. Furthermore, scientists may need to weigh the costs and benefits of bringing back different species and make decisions based on the potential impact on the ecosystem and society as a whole. Overall, the prospect of bringing back extinct species is both exciting and daunting. With advancements in technology, we may be closer to making this a reality than ever before. However, it's important to proceed with caution and to consider the ethical implications of doing so. What do you think? Is it worth exploring the possibility of bringing back extinct species, or are the risks too great? Let us know your thoughts in the comments below. And don't forget to like and subscribe for more informative and entertaining content. Thanks for watching.